Good morning, chemistry student. This is Miss Malatin. Today we're going to learn how to use the electromagnetic spectrum that is on your reference table for chemistry. This spectrum shows all of the known electromagnetic waves. We're familiar with radio waves and microwaves, infrared, ultraviolet, or UV, X-rays, and gamma rays. These are all caused by the same phenomenon. They're photons being emitted, but they have different properties because they have different wavelengths. The wavelength is the distance between the crest or the distance between the cross of succeeding waves. Radio waves have long wavelengths, and that long wavelength means they have a lower frequency. These are all traveling at the same speed if they're in the same medium. So let's say they're traveling through the vacuum of outer space. They'll be going 3 times 10 to the 8th meters per second. Traveling through air or water or other mediums, they slow down a little bit. So lower frequency. And the lower frequency means they have lower energy. So you should go ahead and put this on your reference table. So we go and they get, they're measured in meters, and these are very large, in thousands of meters, and then less than a meter, and then they start getting very, very small. Visible light, it's amazing. We can detect very, very, very short wavelength, and we can tell the difference. It's kind of amazing. And we keep going all the way to gamma, which had the shortest wavelength. So they have the highest frequency. They happen most often. High frequency. And they are the highest energy. So the relationship between wavelength and frequency is inverse. When the wavelength is long, the frequency goes down. When the wavelength is short, the frequency goes up. Now let's check out how to use these. Let's do a fast review. If we have something that is 6.25 times 10 to 7 meters, we know that that's going to be 625 nanometers. We learned that in Unit 2. So let's say we had a photon, the wavelength of 554 nanometers, and we needed to find it on the electromagnetic spectrum. Well, that's in meters, so we would convert that 5.54 times 10 to the negative 7 meters. And now we have to find it. So how we find it is we come here on the electromagnetic spectrum, and it's 10 to the negative 7. So we know that's going to be a little smaller than 10 to the negative 1 times 10 to the negative 6, and a little smaller than 1 times 10 to the negative 7. And we come down here and we're in the UV range, your visible light. We got infrared, visible, and UV. 5.4, let's get this right, times 10 to the negative 7. Let me see, it's greater than 4.9 and less than 5.7. So this would be green light. It's green and it's visible. And that's how you use your electromagnetic spectrum.